Hello and welcome back to Beta Things, the show that brings you the future of mechanical technology in a digital world. As you can see, winter has fallen over over Vancouver Island. I'm super excited to get out on the hills and start snowboarding this year. I'm going to learn how to snowboard, maybe get some skiing in. But today, we're going to be talking about one of my favorite inventions so far, something I've been working on for a long time that I really hope you're going to like. It's a cyclonic herb grinder, and it's like nothing else you've ever seen. Let's get started. Hello and welcome again. I would be Paul Myers, and today we are going to talk about an invention that I'm really excited about, something I've been working on for months now. And this is it. What is it, you say? How could that possibly do anything, you say? It was a project, my goal was to create an herb grinder that used completely different geometry than anything else on the market. So it's based on an auger, or an Archimedes screw, if you're familiar. In agriculture sometimes they'll use a large tube that has a corkscrew in it, and that is able to pull grains and stuff up and then dump it into a silo or whatever. And so it's kind of half based on that, but there's a bit of extra technology and a bit of extra thinking that went into it in order to grind while dispensing. And I'm going to get into that with this video. Just going to consult my notes. It's a live show after all. Yeah, so if you watched my last video, you know that this, along with everything else that I create and have created, is now freely available to download and print off at home and try it out yourself. It's something new I'm trying, and I'm really excited about it.
We've never seen anything like this. It's a whole new world, baby. It's a whole new world.
So this is something that I actually, at one point, had a provisional patent on. It was part of a business arrangement I was involved in several months ago that kind of fell apart. And since then, I've been trying to find someone that is willing to take this to market with me, someone that would be able to bring it somewhere to get injection molded, and we could actually mass produce these things. And I've just been basically running up against a wall trying to get people to buy in, and now that I've made this changeover, I'm really excited actually, because now I get to see these things go out into the world without actually having to put in the effort. I have been selling them through my Etsy page and through opulencemechanics.com, but this is going to be a much faster way to get this idea out into the world. So, first of all, let's hit the tunes. Yeah. That's better. Much more data things. Okay, so let's look at the screen here. So this is it. After, gosh, maybe 40 or 50 prototypes got me to here. The first sort of hurdle, actually let's look more carefully at the actual geometry here first. That's not a good section. I want the front plane. Cool. So, you can kind of see what's going on with this section view. I'll give you a see-through view in a second, but basically you've got a center auger that works just like a regular auger. For this case, you would be turning this bottom ring clockwise or righty-tighty, and that would be bringing stuff up. But what's actually happening that's different than a regular auger is that the outside surface is, let me just make this disappear here for a second. You hide. The outside surface is actually an opposing helix. And so what that does really interestingly, in the way that I saw it many, many months ago when I first started working on this, was it actually creates these pockets. I'll turn off section view here, and then let's look at it with hidden edges, shaded with hidden edges. Make it a bit easier to see here. So what's happening is that the intersection of these two patterns, you get diamond pockets that travel along the outside of the cone and towards the tip. And as they do, they actually decrease in size. So it's grinding and it's crushing. And what it's also doing is, because of the flow towards the tip here, you get flowing in two different directions actually. You get a flow along this outside channel, and then you get a flow in the opposite direction on the inside of the using the impeller. And so it actually splits the direction. It splits the material in half each time one of these pockets gets created. Right at the bottom, it'll be cutting basically, but without actually having the inside and outside pieces touch each other at all. So I think it's pretty cool, and it works really well now. The first month I was working on this, I had the wrong spiral, and what happened was I was applying a regular helix onto a cone. And what happens when you apply a regular helix to a cone is that near where it starts to taper off, the angle of that helix is actually going to straighten up to the point that when it hits the actual tip of the cone, it's at 90 degrees. It's pointing straight up. And so what I had to find out, and what took me about a month to find out, was that I needed to be applying a logarithmic spiral. Now a log spiral is like the spiral, it's like the golden ratio spiral, if you know, versus an Archimedes spiral. So an Archimedes spiral is just evenly going out the same amount all the way. And that's sort of a typical hypnotize you type of spiral. And a logarithmic spiral actually begins to get further and further away. What would be the word? It begins to move away from the center exponentially. And so with every turn, it's getting that much further away from the center. And so when that's applied to a cone, you end up with the same angle of attack all the way up, which is what I wanted. So once that problem was solved, it was working pretty well. But my problem was that the way that I was attaching the cone to the impeller. So what I had been doing there was a snap fit. It was like a barb. So you'd be pushing the cone onto the base until it snaps past a certain point, and then it had a bit of a spin to it. Problem there is with PLA that I'm using, that's a major wear joint. And so after a little bit of use, eventually the plastic would get broken down and they would come apart and it wouldn't work at all anymore. So I tried a bunch of different solutions to try to get that to work, like an overrunning thread and like a screw-on sort of pressure ring that didn't work really well. And then I finally came upon the idea of using airsoft bearings, or airsoft pellets as bearings. And that's what I've got going on down here. So we'll go back to section view for a second. Yeah, there we are. And you can see sort of what's going on. You've got the inside, which is the cone, the outside cone, and the outside, which is attached to the inside impeller. And then this little piece here, which is actually a bearing retainer and bearing spacer. So the way it's assembled would be to screw on the outside ring here, which is actually forming the outside track with this bottom piece. So the full track is actually made when these two pieces come together, which means that you can assemble it rather than like a typical bearing like made out of metal where you do like a hot cold press fit or something. This is quite easy to disassemble. So let's just hide that. you can see, yeah, so this is the bearing spacer retainer. I've got this little band running around the outside to make sure that those ball bearings actually snap into there and stay in during assembly. Hiding that, you would see the inside track. And that's basically it. The outside here, actually, the way that the outside ring attaches on is different than you typically see because of the way that people grab the top of it. They actually end up grabbing that ring too, and so it needs to not over tighten. So what I've used is something that I took from a medicine bottle. This sort of idea of a thread that pulls down to a certain position and then locks, so that you're not over tightening while you're using it. Yeah, so that, yeah, it just locks in like that, and when you want to take it apart, it's not been over tightened, so everything's hunky-dory there. So that's the spiral dilemma, the rotation connector. Let's look at how it prints. So yeah, you can see there, two things that I've added to the model to help it be more printable. Because of the way that the handle on the outside, on the back piece there, kind of cantilevers out and has to print for a long time before it's attached to anything else, I gave it a little foot there that gets cut off. It's about 0.5 millimeter tall, and I did the same sort of thing for the bearing spacer retainer. Gave it this little X thing here in the center that is quite easy to cut off, and then can be used from there, but it makes sure that it stays on there during printing. The lock ring prints upside down, and everything else sort of prints the way you'd expect it to. Yeah, so we got how it prints, how it assembles. Excellent. So I've just pulled that one that you just saw off the printer. So there's a few things that need to be done. Here's my knife. So I'm doing this so that you know how to put it together when you download it and print it and try it out yourself. This is the cross piece here. And if you keep your knife on an angle rather than straight up and down, it makes it a lot easier to cut out. So just run that along the inside ring here. Cut off these pieces, just that. Leaves that behind, that's your waste. There's your bearing spacer retainer, and the handle, which is a little bit more difficult to get off because of this sort of underhang area. But just do your best. At this point, there's no mechanical stuff that are going to interfere. It's just for the looks. So you can take however much time you want to make that look good. You can even hit it with some sandpaper and really clean it up. Yeah, so it would be that piece. Now, depending on what printer you're using or what settings you're using, you might come out with the bearing ring or this ring not sliding on the impeller as well as it should. And so before you put it together, if you, for this case, I just test these two pieces out together, I can feel it. I was using a different printer than I designed it on to print this one, so it's actually tighter. And you'll get it to the point where you could just put it on and then it'll stick. So you really want to make sure before you push it all the way together that you've sanded it. Sand the ring here, sand this little wall here, just so that they slide together, and you're sure of that before you put it together, because you could end up in a situation where you've put these things together, they don't spin, and you can't take it apart, and it'll probably fall apart at an inopportune time. So yeah, make sure that you sand that stuff down. This is one that I've already prepared and sanded, and so it's a reverse thread, because when you're using it, you're grabbing it by that ring and turning it clockwise to tighten it, or to extrude your material, but also it keeps that tight. So what you end up doing to take it apart is turning it backwards, and you pull that bearing ring off, and the whole thing comes apart. Put it back together, just the opposite, put it in, and then you turn this piece, you got your 3 fingers in it, backwards. And that's it. It's all put together. So that's how it's put together. And as you know, as I've said earlier, This is all going to be freely available. I'll have links below to the Thingiverse page so you can try this out yourself. Yeah, thanks for tuning in. Please check out my Patreon page. I've just started it up, and if you can afford to pledge, I'm doing it on a per episode or per creation basis, which means that every time that I create an episode, it'll end up going up on Patreon. The viewers there will see it first, and then it'll be released to everyone else. There's a few other cool perks you can check out as well for different pledge levels. It's patreon.com/betathings. Link will be below. And that's pretty much all I have to say about the Cyclonic herb grinder. Please download it, try it out, and have a good time. You know what? I actually missed one thing, telling you guys about the bearings themselves. I talked about it when I was talking about the model, but yeah, here are the airsoft pellets that I bought. If you can get 6mm steel BB shot, you can use those as well. I haven't been able to find those yet, but you can use any 6mm ball. Would be just fine as these bearings. But for the assembly, you can see I just put the ring over the outside cone here, and then started popping in these little pellets, and they stick in there just fine, and makes it quite easy to use. So that was a bit of a frantic episode, but the music in the background was live, so I'm not going to edit it. Thank you for watching Beta Things. Stick around, and let's keep looking to the future of mechanism together.